This is one of the problems in 5.5, and it says dialysis treatment removes urea and other waste products from the patient's blood by diverting some of their blood flow externally through a machine called the dialyzer. The rate at which the urea is removed from the blood in milligrams per minute is often described well by the equation right here, where R is the rate of flow of the blood through the dialyzer in milliliters per minute, V is the volume of the blood in milliliters, and C sub O is the amount of urea in the blood at the time t equals 0. So you're asked to evaluate the integral. So when you evaluate this, notice that here you have u of t with respect to t. So this is u of t in the equation up here. So we're going to take and plug that in. So what we're doing is we're doing the integral from 0 to 40, and we're going to plug that equation in, dt. That's what it boils down to. So let's work it out down here. We have 0 to 40. U of t is r over v, c sub 0, e to the minus rt over v, and then we have dt. I'm going to move this up because we really only need this equation down here. Now, when you do this, we're integrating with respect to t. That means t is our variable and everything else is a constant. So let's keep that in mind. So when you go to integrate, you're technically integrating this because this is where your t occurs. Now remember, you can only integrate e to the x or e to the u. So the integral of e to the x with respect to x is e to the x. The integral of e to the m with respect to m is e to the m plus c. You can't integrate e to the anything else, so that's why we need to use u sub. So let's let u equal that whole thing. Let's call it negative r over v times t. That's a little easier to see. Do you see that rt over v is the same as r over v times t? Take a minute and process that. It's the same thing. It's just going to be easier to work with, okay? So this is a note board over here. I think I might just if I erase it, it goes away completely. So let's not. Then let's talk about du. So if you think about, if you have y equals 5t, the derivative of that is 5. If you have y equals 8t, the derivative of that is 8. So if you have y or u equals negative r over v times t, the derivative of that is a constant, which is negative r over v, and the derivative of t is dt. So let's solve that for dt. dt then equals negative v over r du. If that does not make sense, back up and think it through again. And then let's plug this in. Now before we do, our bounds are 0 and 40. So we're going to take the u right here, and we're going to say when t equals 40, I would like to use a different color because I got a lot happening. When t equals 40, u is going to be negative r over v times 40, which is negative 40 r over v. And then when t equals 0, anything times 0 is 0, so u stays 0. So our bounds become 0 to negative 40r over v. And then we keep the r over v c sub 0. And here we're going to have e to the u. And in place of dt, we're putting negative v over r du. Does all that make sense? If not, pause it, back it up, do it again, send me a message, make an appointment to talk to me. Now, when we look at this, these cancel, but don't forget this negative. It's a tendency I forget. So I'm going to start with my negative out front. 0 to negative 40r over v. And then we have a constant c sub 0, e to the u, du. We could move the constant out front. Let's do that just so that you see it happening. 0 to negative 40r over v, e to the u, du. Now we talked about up here, when you integrate e to the u, you get e to the u. When you integrate e to the x, you get e to the x. So we're going to bring down our constant, negative c sub 0. When you integrate e to the u, you get e to the u from 0 to negative 40r over v. That doesn't quite look like a v. So we have negative c sub 0, and we're going to say e to the negative 40r over v minus e to the 0. Now remember that e to the 0 is 1, so we're going to put the number 1 in here. And most of the time we don't leave that negative out front. Your book is probably going to distribute and say C sub 0 negative e to the negative 40r over v plus 1. And then we're going to switch it to put the 1 first, just so we don't have a negative. So let me tell you, this technically, so we switched it to 1 minus e to the minus 40r over v. This technically is negative c sub 0 e to the negative 40r over v minus 1. This is a beautiful answer. It is just as correct as this answer down here. So hopefully those make sense. So now let's go and look at the second part. The second part, the answer is going to be the integral is the amount of urea removed in the first whatever minutes we have here, 40 minutes. So the correct answer here is chosen. So the integral gives you the amount of urea you're removing and the amount of time that you've covered. And you covered from 0 to 40 minutes. So that will be the answer. Hopefully that helps you out. I'm going to scroll back down so you can see this final answer in 2 ways. And let me know if you have any questions. I hope that you have a great day.